One last comment on linear independence it has to do with a quantity called the Wronskian. And the Wronskian is a particular quantity that can tell you whether or not a particular function is linearly dependent or not. And the idea is you're going to look at, so let's look at f of x and g of x. And you want to determine whether or not f and g are linearly independent. And so what you do is you look at what's called the Wronskian of f and g. And if you know any linear algebra, this is the determinant of the 2x2 matrix F, G, F prime, and G prime. And if you don't know any linear algebra, that's totally fine. This is F times G prime minus G times F prime. So what you do is you take the product of the terms along the main diagonal and the off diagonal, and then you subtract them. And it turns out that if the Wronskian is 0, then f and g are linearly dependent. And if the Wronskian, conversely, if the Wronskian is non-zero, then f and g are linearly independent. So if the Wronskian is not 0, then f and g are linearly independent. And I just want to show you how this works. So linear dependence implies that, say, g is some constant multiple of f. And if that's the case, think about what's going to happen if you compute the Wronskian. Then the Wronskian of f and g is just going to be f times g prime. So it's f times g prime, which would be c times f prime, minus g, which is c times f prime, which is identically equal to 0. And that's what happens when two functions are linearly, when they're linearly dependent and one's a multiple of the other, so the Wronskian is identically equal to 0, okay, for all x. If that doesn't happen, then the two functions are linearly independent. So for example, you can look at, say, the functions x and x squared. Let's say f of x is x squared, g of x is x. And then the question is, are f and g linearly independent? And there's a few different ways that you could argue here, but arguably the easiest is using the Wronskian. What's the Wronskian of f and g? Well, that's the Wronskian of x squared and x. So that's going to be the determinant of x squared and x, and then their derivatives, 2x and 1. And then that's going to end up being x squared minus 2x squared, which is negative x squared. Since that's not identically 0, f and g are linearly independent. Okay, so since the Wronskian is not the 0 function, then yes, f and g are linearly independent, which I'll call Li for now. Okay, so that's what the Wronskian is. That's what it does for us. It tells us whether or not two functions are linearly independent.